What if mathematics exists even without humans? Imagine that humanity disappears tonight. Not gradually, not after some heroic final chapter, just gone. The cities remain. Satellites continue orbiting Earth, oceans rise and fall, mountains slowly erode, stars burn for millions, billions, perhaps trillions of years. And somewhere in the universe, two stars are separated by a certain distance. That distance can be doubled. A planet can have 3 moons instead of 2. A cluster of galaxies can contain roughly 1,000 times as many stars as another cluster. None of this requires a human being to notice it. But here's the strange question. Does mathematics still exist? If there are no minds left to count, is there still a number 3? If nobody can imagine a triangle, is there still a truth about triangles? If every intelligent creature in the universe disappeared, would prime numbers disappear with them? At first, the question sounds almost childish. Of course, mathematics would still exist, you might say. The universe does not depend on us to keep track of it. But that answer hides a much deeper problem, because there are actually 2 very different things we might mean when we say mathematics. One is the mathematics written in books, taught in classrooms, calculated by computers, and invented by civilizations. The other is the strange abstract structure that seems to describe reality with astonishing precision. And once we separate those 2 things, we run into one of the oldest and most unsettling questions humans have ever asked. Did we invent mathematics, or did we discover it? The answer may change what we think mathematics actually is. A universe without a mathematician. Consider a simple fact. There are 3 rocks sitting on the ground. Before humans existed, could there have been 3 rocks? Almost everyone would say yes. The rocks do not need us to exist. Their physical arrangement does not depend on language. But notice something subtle. The rocks are physical things. The number 3 is not. You cannot pick up 3 and put it in your pocket. You can pick up 3 rocks. You can point at 3 trees. You can see 3 birds. But the number itself seems to be something different from the objects it describes. The rocks can disappear, the trees can burn, the birds can fly away. Yet the relationship between 3 objects and another 3 objects does not seem to change. 3 is 3. It does not age, it does not decay, it does not depend on oxygen, it does not need sunlight. And most strangely, it does not seem to care whether anyone knows about it. This leads to a possibility that has fascinated philosophers and mathematicians for thousands of years. Maybe numbers are not human inventions at all. Maybe we discovered them in the same way we discover continents. Nobody invented Antarctica. Someone eventually found it. Perhaps mathematics works the same way. We did not create the fact that 2 + 2 = 4. We discovered it. But there is a problem with this idea. If mathematics exists independently of human beings, where does it exist? There is no obvious place. You cannot point a telescope at the location of the number 7. You cannot travel to the galaxy where prime numbers live. And yet mathematical truths appear to have a strange kind of reality. This is where the mystery begins. Hack the strange life of numbers. Humans clearly invent mathematical symbols. The symbol 7 is invented. Another civilization could write the same number differently. The word 7 is invented. The language used to describe numbers is invented. Even the notation for equations is invented. But the underlying relationship seems harder to dismiss as invention. Imagine 2 completely isolated civilizations somewhere in the universe. They have never met. They have completely different languages, cultures, bodies, histories, and religions. One day, both civilizations develop mathematics. Eventually, they discover prime numbers. They discover that some numbers can only be divided evenly by themselves and 1. They discover geometric relationships. They discover patterns in circles. They discover that certain equations have particular solutions. They may write everything differently. But if both civilizations are reasoning correctly, they should eventually arrive at the same underlying truths. There is no human parliament voting on whether a prime number should behave like a prime number. No international treaty declares that triangles must have certain properties. No committee of mathematicians decides that infinity should be strange. The rules seem to be waiting for us. And this is one reason mathematics feels so unlike other human creations. We invent chess, we invent traffic laws, we invent currencies, we invent languages. But Once we enter mathematics, we often feel less like lawmakers and more like explorers. We ask questions. Then we discover consequences that we did not choose. A mathematician can define a simple system and then discover that the system contains surprising truths nobody expected. It can feel less like writing a story and more like opening a door. Behind the door is something that was already there. The most beautiful coincidence in science. The mystery becomes even stranger when mathematics begins describing the physical universe. Think about the motion of planets. Long before anyone could send a spacecraft to another planet, humans developed mathematical equations describing orbital motion. Those equations were not merely poetic descriptions. They could be used to predict where planets would be. Mathematics could describe falling objects. It could describe waves. It could describe electricity. It could describe the behavior of gases. It could describe the structure of atoms. Eventually, it became part of our understanding of stars, galaxies, black holes, and the early universe. This is remarkable because mathematics is abstract. A number has no mass. An equation has no temperature. A geometric shape does not physically float through space. And yet these abstract things can describe physical reality with extraordinary accuracy. Physicist Eugene Wigner famously called this the unreasonable effectiveness of mathematics. The phrase captures a genuine puzzle. Why should a mental or abstract system be so useful for understanding a universe made of matter and energy? One possible answer is simple. Maybe mathematics works because the universe itself is deeply mathematical. But that answer immediately creates another question. What does that even mean? Is the universe made of mathematics? Suppose you look at a tree. You see branches, leaves, bark, movement, color. But physics sees something different. It sees matter arranged in particular ways. Atoms, molecules, forces, energy, patterns, measurements, relationships. The more deeply we investigate nature, the more our descriptions become mathematical. The tree is not literally an equation, but the relationships governing its physical behavior can be described mathematically. The same is true of a falling stone. At one level, it is simply a stone falling. At another, it is an object changing position over time. At another, it is a physical system responding to gravity. At a deeper level, its behavior can be represented through mathematical relationships. This raises a radical possibility. Maybe mathematics is not merely a language we invented to describe nature. Maybe mathematics is part of the structure of nature itself. If so, mathematics would not exist because humans exist. Humans would exist because the universe contains mathematical structure capable of producing beings like us. That is a very different way of thinking. It reverses the usual relationship. Instead of saying humans invented mathematics to describe the universe, we might say humans discovered mathematics because the universe has mathematical structure. But we need to be careful. This does not prove that the universe is literally made of numbers. That is a philosophical interpretation, not an established scientific fact. There is an enormous difference between saying that mathematics describes reality extremely well and saying that reality is mathematics. The first is strongly supported by science. The second remains a deep philosophical possibility, and this distinction matters because mathematics can describe things that do not physically exist. The mathematics of impossible worlds. Consider a perfect circle. You can draw a circle on paper, but the circle you draw is never perfectly circular. The paper has thickness, the ink has thickness, your hand is imperfect. At a microscopic level, the boundary is irregular. Yet mathematics can define a perfect circle. Every point on its edge can be exactly the same distance from its center. Such a circle may never exist physically, and mathematics has no problem talking about it. The same is true of perfectly straight lines, perfect triangles, infinite sets, numbers with infinitely many digits, spaces with dimensions beyond our ordinary experience. Mathematics can explore structures that may have no physical counterpart at all. This creates a problem for the idea that mathematics simply is physical reality. If mathematics contains structures that nature never realizes, then mathematics seems larger than the physical universe. Or perhaps physical reality realizes far less mathematics than mathematics contains. Imagine mathematics as an enormous library. Our universe may be only one book, maybe a few shelves, maybe an entire section, but the mathematical library could contain structures that no physical universe ever uses. If that is true, then the mathematical world may be vastly larger than our physical one. And suddenly the question changes. Instead of asking, why does mathematics describe our universe, we can ask, why does our universe happen to be one in which some mathematics becomes physically meaningful? That question is much harder. The mathematical world we cannot see. There's a famous philosophical position sometimes called mathematical Platonism. The basic idea is surprisingly simple. Mathematical objects are real, but they do not exist physically. Numbers, shapes, sets, and mathematical relationships exist in an abstract realm. Humans do not create them. We discover them. If humans disappeared tomorrow, the truth that prime numbers have certain properties would remain true. Under this view, mathematics is not located inside the human brain. The brain is merely one way of accessing it. This sounds strange because we are used to thinking that abstract ideas live inside minds. Your memory of yesterday is in your brain. Your imagination of a dragon is in your brain. Your idea of a fictional character is in your brain. So perhaps mathematical ideas are also simply patterns created by brains. Maybe there is no mysterious mathematical realm. Maybe mathematics is a sophisticated human invention that has become incredibly useful because human brains evolved to detect patterns. This is a serious alternative, and it has something going for it. Humans are pattern-seeking creatures. We evolved in environments where recognizing patterns was useful. A shadow moving in the grass might indicate an animal. Certain clouds might signal a storm. The position of objects could matter for hunting and navigation. Our brains became extremely good at detecting relationships. Mathematics could be an extraordinary extension of this ability. In this view, the universe does not contain three as an abstract object. It contains physical arrangements. We impose the concept of three upon them. We do not discover numbers. We create a conceptual framework that allows us to organize experience. This explanation is attractive, but then we face the problem of mathematics predicting things we did not know were there. When mathematics gets ahead of reality. One of the strangest moments in the history of science occurs when mathematics predicts something before anyone observes it. Scientists sometimes develop mathematical theories because they make sense internally. The equations produce unexpected consequences. At first, those consequences may seem purely abstract. Then, years later, experiments reveal that nature actually behaves that way. This has happened repeatedly throughout the history of physics. Mathematical theories have led scientists toward things they were not specifically looking for. A famous example involves antimatter. In the early 20th century, physicist Paul Dirac developed an equation combining quantum mechanics with Einstein's theory of special relativity. The mathematics suggested the existence of a particle with the same mass as the electron, but opposite electric charge. At the time, such a particle had not observed. It sounded strange, yet the positron was later discovered. The mathematics had pointed towards something physically real. This does not prove that mathematical objects exist independently of humans, but it makes the story much more mysterious. Why can abstract reasoning reveal hidden features of physical reality? Perhaps because mathematics is an especially powerful way of expressing relationships. Perhaps our theories are carefully designed to match observations. Perhaps mathematics is the underlying structure of the universe. Or perhaps something even stranger is happening. We do not yet know. Imagine removing every human mind. Let's perform a thought experiment. Imagine that humanity disappears. But not just humanity, every intelligent species disappears. No aliens, no animals capable of abstract reasoning, no computers, no artificial intelligence, no observers, no language, no memory, no consciousness. The universe continues, stars explode, black holes merge, planets orbit, particles interact, galaxies collide. Now imagine that somewhere in this universe, two particles interact in a way that can be described by a mathematical equation. Does the equation still exist? One answer is yes. The physical relationship remains. The equation is simply a human description of it. Another answer is no. There is no equation anywhere because there is no mind to formulate it. The physical event still occurs, but the mathematics describing it does not exist as an actual thought or symbol. Both answers seem reasonable, and that tells us something important. The question may contain an ambiguity. Does mathematics exist could mean, does mathematical truth exist, or does a mathematical description exist? Those are not the same thing. A map does not create the territory, but without a map maker, there is no map. Perhaps mathematics is similar. The universe contains patterns and relationships. Humans create symbolic systems for representing them. The symbols are ours. The structures may not be, but even that distinction becomes difficult when we reach pure mathematics. What about mathematics that has nothing to do with nature? Imagine a mathematician invents a strange new system. She defines objects that behave according to certain rules. At first, the system seems completely disconnected from physics. No one knows whether anything in nature corresponds to it. She spends years exploring its properties. Decades later, another scientist discovers that the same mathematical structure provides a useful description of a physical phenomenon. This kind of connection has happened in different forms throughout mathematics and physics. It creates a strange feeling. Was the mathematician inventing the structure, or discovering something that the universe had been using all along? Suppose the second explanation is true. Then mathematics could be compared to an enormous landscape. Humans walk through it, naming mountains. But the mountains existed before the names. A different civilization might give them different names. The names are invented, the landscape is discovered. This analogy explains why mathematicians sometimes talk about discovery. But it still does not answer the most difficult question: what kind of existence does the landscape have? A physical mountain exists somewhere in space. A mathematical structure does not seem to exist in that same way. It cannot be photographed, it cannot be weighed, it cannot be destroyed with fire. So perhaps mathematical existence is a different category altogether. The strange case of infinity. Nothing reveals the mystery better than infinity. Take the natural numbers, 1, 2, 3, 4, 5. You can always add one more. There is no final natural number. That simple fact leads to an enormous mathematical world. Mathematicians can distinguish different kinds of infinity. Some infinite collections can be placed into a one-to-one correspondence with the natural numbers. Others are larger in a meaningful mathematical sense. This is difficult to imagine because our physical experience does not contain anything quite like it. Every physical object we encounter appears finite. Even the observable universe has a finite age. Yet mathematics can reason about infinite structures with remarkable precision. Where does infinity exist? Not on a shelf, not in a galaxy, not inside a box. If there are no minds, does infinity remain? A Platonist might say yes. Infinity is an abstract truth independent of observers. A more human-centered view might say that infinity is a concept created by minds to reason about endless processes. Neither position is easy to prove, and perhaps that is the point. Mathematics sits in an unusual territory between imagination and reality. It is invented through human activity, yet often behaves as if it has a life of its own. Could aliens discover the same mathematics? Now imagine receiving a message from another civilization. You decode it. The symbols are completely unfamiliar. The language is impossible to understand, but eventually you find something interesting. A sequence, 2, 3, 5, 7, 11, 13 prime numbers. You realize what you are looking at. The aliens may have completely different bodies. They may live under a different kind of star. They may perceive colors we cannot imagine. Their brains may work in ways that are nothing like ours. Their civilization may be millions of years older. Yet, they have discovered prime numbers. That would be unsurprising, because prime numbers do not belong to Earth. But suppose they also discovered the same geometric relationships, the same mathematical truths, the same properties of numbers. Then mathematics would look less like a human cultural invention and more like something universal. Perhaps mathematics would become the closest thing we have to a universal language, not because everyone agrees on symbols, but because correct mathematical relationships do not depend on culture. An alien might draw a triangle differently, but a correctly reasoned mathematical relationship would remain the same. This is one reason mathematics is often considered a candidate for communication with extraterrestrial intelligence. It is based on relationships rather than words. But even this idea has a hidden assumption. We are assuming that another intelligence will recognize mathematical structure in roughly the same way we do. What if they don't? Maybe mathematics is a human way of seeing. There is another possibility. Perhaps mathematics is not a universal language. Perhaps it is a universal compression tool created by intelligent minds. The universe contains an overwhelming amount of information. Every leaf has a different shape. Every wave is different. Every particle interaction can be described in enormous detail. Mathematics allows us to compress patterns. Instead of memorizing the path of every falling object, we can describe a general relationship. Instead of recording the position of every planet at every moment, we can use equations. Instead of memorizing every possible triangle, we can describe relationships that apply to all triangles. Mathematics is powerful because it takes many observations and reduces them to a small set of rules. In that sense, perhaps mathematics is something like a very efficient language for patterns. The universe provides the patterns. Minds provide the abstraction. This view does not require a mysterious mathematical realm. But it still leaves one question unanswered. Why is the universe so full of patterns that can be compressed mathematically? Why is reality not just meaningless chaos? The universe could have been different. Imagine a universe with completely different laws. Suppose gravity did not weaken with distance in the way it does here. Suppose matter behaved differently. Suppose stable atoms could not exist. Suppose there were no stars. Suppose time behaved in a completely different way. Would mathematics still exist? Probably. There would still be mathematical truths, but the mathematics relevant to that universe might be very different. Perhaps certain structures would become physically meaningful while others would remain purely abstract. This suggests that we should separate two questions. Does mathematics exist? And why does our particular universe obey the mathematical structures it does? The first may be philosophical. The second is deeply connected to physics. Scientists search for mathematical descriptions of nature because observations suggest that the universe follows regular patterns. But why those patterns? Why these laws rather than others? We have no final answer. We can describe gravity, we can measure it, we can build theories about it. But we cannot currently explain, in some ultimate sense, why reality has these laws instead of completely different ones. This is where physics begins to approach metaphysics. The universe does not owe us simplicity. There is something else worth noticing. The laws of nature often look surprisingly simple when written mathematically, but simplicity may be partly a feature of how we describe things. Imagine looking at a forest. At first, it appears impossibly complicated. Thousands of trees, millions of leaves, countless movements. But then you discover a few underlying rules governing growth, energy, and competition. The complexity emerges from simple relationships. Mathematics is particularly good at finding this kind of hidden structure. A few rules can generate enormous complexity. This happens in weather, biology, fluid motion, population growth, and many other systems. So perhaps mathematics seems mysterious because reality contains simple rules capable of producing extraordinary complexity. We see chaos. Mathematics searches underneath it. Sometimes it finds order, sometimes it finds deeper chaos, and sometimes it discovers that the boundary between order and randomness is itself mathematically structured. Could mathematics exist in a universe with no consciousness? Now we can return to the original thought experiment. Imagine a universe containing absolutely no consciousness, no observers, no thoughts, no language, no mathematics textbooks, no computers, no mathematicians, only physical processes. Would mathematics exist? There are at least three broad possibilities. The first says yes. Mathematical truths are objective. They do not depend on minds. A triangle has certain properties even if nobody knows what a triangle is. The second says no. There would be physical relationships, but mathematics would not exist until an intelligent system represented those relationships using concepts and symbols. The third is stranger. Maybe mathematics exists in one sense, but not another. The physical universe contains objective structures. Mathematical minds discover and represent those structures. So mathematics is neither purely invented nor purely found. It is an interaction between reality and intelligence. Perhaps the universe supplies the structure. The mind supplies the abstraction. Mathematics happens where the two meet. This third possibility may be closer to how mathematics actually feels. We invent notation, we choose definitions, we create formal systems, But once those systems are established, we often discover consequences that we did not choose. It is as if we build the telescope but do not build the stars. The curious problem of definitions. Someone might object, of course mathematical truths exist, but mathematicians define the objects themselves. And that is partly true. We can define a mathematical game. We can invent rules. For example, we can create a new type of object and specify how it behaves. But after we define the rules, we cannot freely decide every consequence. Suppose you invent a chess-like game. You choose the rules, but once the rules are fixed, certain positions become winning positions. You may not know which ones. The consequences are waiting to be discovered. Mathematics can work similarly. We construct formal systems, then we explore what follows from them. This is one reason mathematics can feel both invented and discovered. The doorway may be built by humans, but what lies beyond the doorway can surprise us, and sometimes the surprises are enormous. The limits of what mathematics can tell us. There is another twist. Mathematics is powerful, but it is not magical. In the 20th century, mathematician Kurt Gödel showed that certain sufficiently powerful mathematical systems contain statements that cannot be proven within those systems, assuming the systems are consistent. In simple terms, mathematics can contain questions that cannot be settled using the rules of the system itself. This does not mean mathematics is broken. It means formal reasoning has limits. There are boundaries between what can be demonstrated, what can be calculated, and what can simply be true. This makes the original question even more interesting. If mathematical truth exists independently of minds, then perhaps reality contains truths that no mind can ever fully uncover. There could be mathematical facts that are true, even though no human, alien, or machine ever proves them. Imagine a library containing infinitely many books, some of which no reader can ever reach. The books exist, but their contents remain unknown. That is one possible picture of mathematics, and if it is correct, then human mathematics might be only a tiny window into something vastly larger. What if nobody ever discovers most of mathematics? Think about the age of the universe. The universe is roughly 13.8 billion years old. Human civilization, by comparison, is extremely young. Modern mathematical science is younger still. Written mathematics has existed for only a tiny fraction of cosmic history. If mathematics is an enormous landscape, humanity has barely taken its first steps. We may have discovered only a microscopic portion. There could be mathematical structures so strange that our current minds cannot even imagine them. There could be relationships that require forms of reasoning we have not developed. There could be entire areas of mathematics that no civilization ever discovers. And if mathematics is independent of minds, those undiscovered truths would not wait for us. They would simply remain undiscovered. This idea changes the meaning of mathematical ignorance. When we do not know something in physics, we usually imagine that the answer exists somewhere in nature. Perhaps mathematics is similar. There may be answers that exist independently of anyone knowing them. But this creates an almost uncomfortable thought. Reality may contain more truths than intelligence can ever understand. What if mathematics is bigger than the universe? Now push the idea one step further. Suppose mathematical Platonism is correct. Then mathematical structures exist independently of physical reality. If so, our universe may be only one possible realization of some mathematical structure. Other mathematical structures may describe other possible universes. Some may contain space, some may contain time, some may contain neither. Some might permit complex forms of matter. Some might contain no physical matter at all. This sounds like science fiction, and it is important to say that it is speculative. There is no established evidence that every mathematically possible structure physically exists. But the idea raises a fascinating philosophical question. Why should physical reality be limited to the mathematical structures we happen to observe? Perhaps there are infinitely many mathematical possibilities, while physical reality selects only one. Or perhaps reality is itself mathematical, and what we call possible universes are simply different mathematical structures. These ideas are associated with various philosophical and cosmological proposals, but none should be confused with established scientific fact. The interesting part is not whether one of them is secretly true. The interesting part is that mathematics allows us to imagine possibilities far beyond ordinary physical intuition. It becomes a laboratory for asking what reality could be. Maybe reality is the strange part. We often say mathematics is strange. Numbers are invisible. Infinity is impossible to picture. Higher dimensions are difficult to imagine. Abstract structures seem detached from everyday life. But perhaps we are looking at the problem backward. Maybe mathematics is not strange, maybe physical reality is. Consider what exists around you right now. Matter, space, time, consciousness. You experience all of this as normal because you have never known anything else. But think about it for a moment. Why is there something rather than nothing? Why is there a universe? Why does it have laws? Why can matter form stars? Why can stars create heavier elements? Why can those elements form planets? Why can planets develop chemistry? Why can chemistry produce living systems? Why can living systems produce brains? Why can brains ask questions about mathematics? From one perspective, this entire chain is astonishing. The fact that we can even sit here and ask whether mathematics exists without us may itself be one of the strangest facts in the universe. Mathematics and consciousness meet in a strange place. There is another mystery hiding here. Mathematics is abstract. Consciousness is subjective. Yet somehow, conscious beings can think about abstract mathematical structures. You can close your eyes and imagine a triangle. You can understand that the triangle you imagine is not physically present. You can reason about a shape that exists only as an idea. You can imagine infinity even though you cannot physically experience infinity. Your brain is made of physical matter. Neurons exchange chemical and electrical signals. And yet, those physical processes produce thoughts about objects that may not physically exist. This creates a remarkable bridge. Physical matter, brain activity, abstract thought, mathematical truth. We do not fully understand consciousness itself. So, we should be cautious about making strong claims about the relationship between consciousness and mathematics. But the connection is undeniably strange. A universe made of physical processes has produced beings capable of contemplating entities that may not be physical at all. Perhaps this is just an unusual ability of brains. Perhaps consciousness has access to a world of abstract structure. Or perhaps mathematical thinking is simply what happens when a sufficiently complex system becomes capable of representing patterns recursively. Again, we do not have a final answer, but the mystery is real. Shaksh, what would mathematics look like to a mind completely different from ours? Imagine an intelligence that does not experience space visually. Maybe it experiences the universe through relationships alone. It does not see objects. It perceives connections. To such a being, geometry might feel as natural as color feels to us. Now imagine another intelligence that experiences time differently. Perhaps it does not think moment by moment. Perhaps its awareness includes an enormous stretch of events simultaneously. Would its mathematics look different? Possibly. The underlying truths might remain the same while the intuitive ways of discovering them changed. This distinction is important. Human mathematics may be shaped by human cognition. Our symbols, metaphors, preferred methods, and intuitions are influenced by the kind of brains we have. An alien civilization might develop completely different mathematical intuition, yet they might still encounter the same structures. That would be fascinating. It would suggest that mathematics has an objective core surrounded by many different ways of understanding it, like a mountain seen from different sides. The views differ. The mountain does not. So did we invent mathematics? Perhaps the best answer is, we invented mathematics in one sense and discovered it in another. We invented the symbols. We invented the notation. We invented names. We invented formal systems and chose which questions to investigate. We invented ways of teaching mathematics. But once the rules are established, we encounter consequences we did not freely choose. And when mathematics successfully describes nature, it seems to reveal something about the world that is not merely a product of human imagination. This makes mathematics unusual among human creations. A novel is invented. A mathematical theorem is proved. A language is constructed. A mathematical consequence is discovered. A game has rules chosen by people. Mathematics can have rules chosen by people, but consequences that escape their control. Perhaps mathematics is best understood as a conversation between invention and discovery. we choose the questions. Reality or abstract structure chooses many of the answers. The final puzzle, return to the empty universe. Humanity is gone. Every alien is gone. Every conscious creature is gone. No one is counting. No one is measuring. No one is thinking. The universe continues. A star collapses, two black holes merge. Light crosses empty space. Particles interact. Galaxies move. Now ask again, does mathematics exist? If you answer yes, you are making a remarkable claim. You are saying that mathematical truth does not depend on minds, that numbers, structures, and relationships have a kind of existence beyond physical objects and conscious experience. If you answer no, you are making a different remarkable claim. You are saying that mathematics requires intelligence. Without minds, there are only events. No numbers, no equations, no geometry, no mathematical truths in any meaningful sense. And perhaps there is a third answer. Maybe the universe contains structures that are mathematical in a deep sense, but mathematics as we know it appears only when a mind notices those structures and gives them names. In that case, humans did not create the universe's patterns, but neither did the universe write our textbooks. We are the interpreters. We look at reality and notice that one arrangement resembles another. We notice repetition, symmetry, quantity, change, probability, order. We give these things names, then we discover that the names lead somewhere. We follow the trail, and sometimes it takes us to places we never expected. The strange possibility that mathematics was here first. There is something almost poetic about all of this. Long before the first human looked at the night sky, stars were moving according to patterns. Long before anyone understood geometry, planets traced paths through space. Long before anyone wrote down numbers, physical systems contained quantities and relationships. Long before anyone knew what a prime number was, the structure of the integers, if mathematical structures exist independently, was already there. And yet mathematics, as a human activity, required someone to notice. That may be the deepest mystery. Perhaps mathematics is a hidden landscape. Perhaps the universe is full of structures that do not need us. But consciousness gives those structures a voice. A star does not need to know the equation describing its motion. A galaxy does not need to understand geometry. A black hole does not need to calculate anything. Nature simply behaves. We are the strange creatures who look at that behavior and ask why. We turn movement into equations. We turn patterns into numbers. We turn relationships into symbols. And then, sometimes those symbols reveal things that our senses could never have shown us. That is almost impossible to ignore. Maybe mathematics is not evidence that the universe was designed for human beings. Maybe it is evidence of something more subtle. We happen to live in a universe whose patterns can be understood by minds like ours. And perhaps that is not as ordinary as it feels. The universe existed for billions of years before we appeared. If mathematics is independent of humanity, then the mathematical structures we study were not waiting for us in the way a book waits for a reader. They were simply there. If mathematics is created by minds, then something equally strange has happened. A universe that began without minds eventually produced minds capable of inventing an abstract language powerful enough to describe the universe itself. Either way, the story is extraordinary. Because when you write down an equation, you may be doing one of two things. You may be creating a new way of thinking, or you may be touching something that was already there before the first thought ever existed, and we still do not know which is stranger. Maybe mathematics exists without humans. Maybe it doesn't. But the fact that the question can even be asked suggests something profound about our place in reality. We are made of the universe, friend, and somehow the universe has produced creatures capable of wondering about the rules that made them. The stars do not ask what mathematics is. We do. And perhaps the most mysterious mathematical fact of all is not that numbers can describe the universe. It is that the universe contains capable of discovering that they can.